And our journey into the world of circle continues. We are yet to unfold another quest for today. Good morning, my dear grade 10 Valenzuelanos. I welcome you to second quarter, week 6 Valenzuela live session on mathematics. As usual, please be sure that you have your learning packets at your side, together with your ballpen and a notebook. Last live session, we have illustrated tangents, secants, sectors, and segments. The focus of today's live streaming would be to prove and apply theorems on secants, tangents, and segments. But before that, let us first have a recall activity. All you have to do is to apply everything that you have learned so far about circles by giving the measure of each indicated term related to the given circle R. I will give you 10 seconds to key in your answers for each item. The given circle can be seen on your screen. Our given is the measure of angle QRT, which is 88 degrees. Are you ready? Let us kick off this activity. Number 1. Give the measure of arc QT. Again, give the measure of arc QT. Timer starts now. Can do it. All right, time's up. Arc QT is the intercepted arc of the central angle QRT. Let us recall that the measure of the central angle is just equal to the measure of its intercepted arc. Therefore, if the measure of angle QRT is 88 degrees, we can say that arc QT is also 88 degrees. So if your answer is 88, you are correct. Let's have the second given. What is the measure of the major arc QPT? Again, what is the measure of the major arc QPT? Timer starts now. Comment your answers. Last 4 seconds. Okay, time's up. Now take note that arc QT is 88 degrees. The measure of its corresponding major arc QPT, the blue one, or the one in blue, is 360 degrees minus the measure of the minor arc. We have 360 degrees minus 88 degrees. And that is 272 degrees. Good job. Let us have item number 3. What is the measure of angle QPT? Again, what is the measure of angle QPT? You have 10 seconds to comment your answers. You still have 4 seconds. Okay, time's up. Angle QPT is an inscribed angle. Remember that the measure of an inscribed angle is half the measure of its intercepted arc. In the figure, arc QT, which measures 88 degrees, is the intercepted arc of angle QPT. Therefore, the measure of angle QPT is half the measure of arc QT. 88 divided by 2 is 44 degrees. Great. Item number 4. What is the measure of arc ST? Again, what is the measure of arc ST? You can type your answers now. Last 3 seconds. Okay, time's up. Arc ST, that is the intercepted arc of the central angle SRT. Angle SRT and angle QRT are linear pairs. Let me repeat that. Angle SRT and angle QRT are linear pairs. The sum of their measures is 180 degrees. So the measure of angle SRT is 180 minus 88. and that is equal to 92 degrees. So, the measure of arc ST is 92 degrees. That's correct. Last item. What is the measure of arc PS? Again, what is the measure of arc PS? You have 10 seconds. All right, time's up. Arc PS is the intercepted arc of the central angle PRS. Now, angle PRS and angle QRT are vertical angles, meaning to say they have the same measures. We have a theorem stating that if central angles are congruent, their corresponding intercepted arcs are also congruent. So, if the measure of arc QT and angle QRT is 88 degrees, then the measure of arc PS is also 88 degrees. So if your answer is 88 degrees, you are correct. So for today, we will be adding more things in your pool of knowledge about circles, as we will be talking about theorems on angles and segments formed by tangents and secants. I will be introducing 4 theorems for this lesson. And for the sake of this lesson, I will be calling them theorems 1 to 4. Let us start with theorem number 1. I'm going to read theorem number 1. The measure of an angle formed by 2 secants of a circle intersecting at a point in the interior of the circle is 1/2 the sum of the measures of its intercepted arcs. Let me repeat that. The measure of an angle formed by 2 secants of a circle intersecting at a point in the interior of the circle is 1/2 the sum of the measures of its intercepted arc. Alright, so this theorem is applicable when you have 2 secants intersecting in the interior of the circle. So for example, we have this given circle. So that is 36 degrees. And this one is 44 degrees. To get the measure of this angle, that is 36 plus 44, and that is 80. 80 divided by 2 is 40. Therefore, this is 40 degrees. How about the angle over here, the one on top? What's the measure of that angle? Now, since they are linear pairs, this is 180 degrees minus 40 degrees. And so this is 140 degrees. Let us now try to use letters to represent points. Right? Like this one. Based from the theorem given, to get the measure of angle FED, we need to get 1/2 the sum of arc AB and arc FD. Well, at this point, you may be questioning the theorem. Like, why 1/2? Why do we need to get the sum, etc.? So let's try to prove the theorem. To prove the theorem, by construction, let us draw line segments AF and BD, thus forming triangles AFE and BDE. So, we want to prove that the measure of the angle formed by 2 secants intersecting inside the circle is 1/2 the sum of its intercepted arcs. Specifically, in this illustration, the measure of angle FED is 1/2 the sum of the measures of arc AB and arc FD. Let us use a 2-column proof consisting of statements and reasons. Statement number 1. We have secants AD and BF intersecting at point E within circle C. And of course, we always start with your given. Ayan. So, for statement number 2, angle EAF and angle AFE are inscribed angles. And this is because of the definition of an inscribed angle. As you can see on the figure, angle EAF and angle AFE are really inscribed angles. Their vertices are on the circle itself. Statement number 3. The measure of angle EAF is equal to 1/2 the measure of arc FD. And the measure of angle AFE is 1/2 the measure of arc AB. And our reason for that is because the measure of an inscribed angle is 1/2 the measure of its intercepted arc. We know that theorem, and you already discussed that theorem. Let's go to statement number 4. Angle FED is an exterior angle of triangle EAF. Again, angle FED is an exterior angle of triangle EAF. Angle EAF and angle AFE are its remote interior angles. This is by the definition of an exterior angle in its remote interior angle. Statement number 5. The measure of angle FED is now equal to the measure of angle EAF plus the measure of angle AFE. This is by the remote interior angle theorem. Statement number 6. Measure of angle FED is equal to 1/2 the measure of arc FD plus 1/2 the measure of arc AB. This is by substitution from numbers 3 and 5. So the corresponding measures have been substituted. And last, for number 7, the measure of angle FED is equal to 1/2 the sum of the measures of arc FD and arc AB. And this is by factoring. So therefore, we have proven the given statement. So for example, let's have an example here. If the measure of arc QR is 86 degrees and the measure of arc UT is 70 degrees, what is the measure of angle QSR and the measure of angle QSU? So let's use that given. We have the measure of angle QSR is 1/2 the sum of the measures of arc QR and arc UT. We just substitute their corresponding values. So measure of angle QSR is 1/2 the sum of 86 degrees, the measure of arc QR, and 70 degrees, the measure of arc UT. We just perform the corresponding arithmetic. We have the measure of angle QSR is 78 degrees. So that's one of the items that we are looking for, the measure of angle QSR. Let's now proceed to the measure of angle QSU. Take note that QSR and QSU are linear pairs. Again, if they are linear pairs, the sum of their measures is equal to 180 degrees. Therefore, the measure of angle QSU is just 180 degrees minus 78 degrees. And that is 102 degrees. Right? So you try this now. If the measure of arc QU is 87 degrees and arc RT is 73 degrees, what is the measure of angle QSR? Again, if the measure of arc QU is 87 degrees and the measure of arc RT is 73 degrees, what is the measure of angle QSR? Comment your answers. You have 10 seconds. Last 1 second. All right, time's up. So the measure of angle QSU, we are first going to get QSU before we get QSR. They are just linear pairs, by the way, no? So measure of angle QSU is 1/2 the measure of arc QU and arc RT. So therefore, we have 1/2 the sum of 87 degrees and 73 degrees. And that is 80 degrees. Now take note, we are looking for angle QSR and not QSU. So the measure of angle QSR is now 180 degrees minus 80 degrees. So our final answer would be 100 degrees. So if you have answered 100 degrees, you are correct. You have understood theorem number 1 very well. Let us have the next theorem. The next theorem states that the measure of an angle formed by two secants, two tangents, or a secant and a tangent intersecting in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. Let me repeat that. The measure of an angle formed by two secants, two tangents, or a secant and a tangent intersecting in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. For this theorem, this is applicable when you have two secants, two tangents, or a secant and a tangent intersecting in the exterior of the circle. Take note that for theorem number 1, the point of intersection is inside. For this theorem, the point of intersection is outside. The main difference is that for theorem 1, we use addition. For this theorem, we are going to apply subtraction. Again, let me just emphasize, this theorem is applicable for these cases, right? So for example, we have the bigger arc here, which is 100 degrees, while the smaller arc is 40 degrees. To get the measure of the angle formed by the intersection of the two secants, we need to subtract the measures of the two arcs. So 100 minus 40, that is 60 degrees. And we get half of the difference. 60 divided by 2 is 30 degrees. That's how you apply theorem number 2. Using points, we have this. We have the measure of angle CAB is half the difference of the measures of arcs CB and ED. For the sake of proving, we construct line segment EB. Again, that is by construction. So again, we want to prove the given theorem that when two secants intersect in the exterior of the circle, the measure of the angle formed is 1/2 the difference of the intercepted arcs. Specifically, the measure of angle CAB is 1/2 the difference of the intercepted arcs. Right? Or that is 1/2 the difference of arc CB and arc ED. So let's now use again the two-column proof consisting of statements and reasons. Statement number 1. Secants AC and AB intersecting outside the circle. Of course, we always start again with your given. Second statement. The measure of angle the measure of angle CEB is 1/2 the measure of arc CB. That is, the measure of an inscribed angle is 1/2 the measure of its intercepted arc. As you can see in the figure, CEB is an inscribed angle. So therefore, we can write this statement. Statement number 3. The measure of angle EBD is 1/2 the measure of arc ED. As you can see also, EBD is also an inscribed angle. So we can have this. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. Statement number 4. The measure of angle EAB plus the measure of angle EBD is equal to the measure of angle CEB. This is by the remote interior angle theorem. We have the triangle BEA and we have its two interior angles. We have EAB and EBD. And the remote exterior angle is CEB. Therefore, we have this equation. Statement number 5. The measure of angle EAB is equal to the measure of angle CAB. This is by the definition of congruent angles. As you can see on the figure, angle EAB and angle CAB pertains to the same angle. They are basically the same angle, so therefore they are congruent. Statement number 6. Measure of angle CAB plus measure of angle EBD is equal to the measure of angle CEB. This is by substitution from numbers 4 and 5. Right? So continuing, we have number 7. The measure of angle CAB is equal to the measure of angle CEB minus the measure of angle EBD. This is by the addition property of equality. You just add negative measure of angle EBD to both sides of the equation. Then we have number 8. The measure of angle CAB is now equal to 1/2 the measure of arc CB minus 1/2 the measure of arc ED. This is by substitution. If you can recall earlier, we have stated that the measure of angle CEB is 1/2 the measure of arc CB, and the measure of angle EBD is 1/2 the measure of arc ED. So we just substitute their corresponding measures. And statement number 9, the measure of angle CAB is 1/2 the difference of the measures of arc CB and arc ED. And this is by factoring. For example, let's apply the theorem. The measure of arc HJ is 80 degrees. And the measure of arc LJ is 150 degrees. Find the measure of angle LKJ. Again, the measure of arc HJ is 80 degrees. And the measure of arc LJ is 150 degrees. We are to find the measure of angle LKJ. So again, we have the formula. The measure of angle LKJ is just 1/2 the difference of the measures of arcs LJ and arc HJ. So again, we just substitute corresponding values. We have that is equal to 1/2 the difference of 150 degrees and 80 degrees. And if we solve that, we have 35 degrees. Therefore, the measure of angle LKJ is 35 degrees. Let's have another example. This time, the measure of arc LJ is 160 degrees, and the measure of angle LKJ is 35 degrees. Find the measure of arc HJ. This time, we are looking for the measure of the arc and not the angle. So again, we use this formula. The measure of angle LKJ is 1/2 the difference of the measures of arc LJ and arc HJ. Then we just substitute corresponding values. So measure of angle LKJ is 35 degrees. So we substitute that. 35 degrees is equal to 1/2 the difference of 160 degrees minus the measure of arc HJ, the one we are looking for. Then we just multiply 2 to the whole equation. We now have 70 is equal to 160 degrees minus the measure of arc HJ. Then the measure of arc HJ is now 160 degrees minus 70 degrees. That is by using the addition property of equality. We subtract that, our final answer would be 90 degrees. Right? So I hope you have understood the concept at this moment. So you try this now. For example, the measure of arc EB is 76 degrees. And the measure of arc BDC is 160 degrees. Find the measure of angle BAC. Again, the measure of arc EB is 76 degrees. The measure of arc BDC is 160 degrees. Find the measure of angle BAC. You have 10 seconds to comment your answers. Alright, time's up. You have answered 42 degrees. You are correct. You have understood the theorem. So here's your solution. And you get 42 degrees here. So another one. You try this one. The measure of arc BDC is 170 degrees. The measure of angle BAC is 48 degrees. Find the measure of arc EB. You have 10 seconds to comment your answers. You can do it. Alright, time's up. If you have answered or if you have written 74 degrees, again, you are correct. Then again, we have our solution over here. Okay? Let's now proceed to theorem number 3. If two secants intersect in the exterior of a circle, then the product of the lengths, let me repeat that. If two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. So for this theorem, we have this figure given. You should be having two secants intersecting outside or in the exterior of a circle. So what does the theorem state? So in simplified version, we have this one. We have AE times BE is equal to DE times CE. That is the length of the secant segment, the whole AE, times BE, the length of the secant segment outside the circle. So we have AE times BE is equal to DE. Again, the length of the whole secant segment times CE, the length outside the circle. Okay? So let us try this example, no? We have the measure of DE is 24 centimeters. The measure of BE is 6 centimeters. The measure of AB is 10 centimeters. We are to look for the measure of CE. Right? So again, we have AE times BE is equal to DE times CE, applying theorem number 3. Then we just substitute corresponding measures. We have AE, as you can see from the figure, AE, that is AB plus BE. So therefore, that is 10 plus 6. Times the measure of BE, 6, is equal to DE, that is 24 times CE, the one we are looking for. So 10 plus 6, that is 16. Therefore, we have 16 times 6 is equal to 24 times CE. We solve that, we will get CE is equal to 4 centimeters. And that's how you apply theorem number 3. Let's proceed to theorem number 4. If a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external secant segment is equal to the square of the length of the tangent segment. Right? So this theorem wants to state this equation. We have AE times BE is equal to the square of CE. That is, for the secant part, we have the length of the secant segment times the length outside the circle. So we have AE times BE is equal to the length of the tangent segment. So CE, then we square that. That's how you apply theorem number 4. Let's have an example. For example, here you have CE is 20 centimeters. AB is 9 centimeters. We are looking for the length of BE. For the sake of this example, I will let X be equal to BE. Right? So again, we have this. AE times BE is equal to the square of CE. Then we just substitute corresponding values. So AE, that is AB plus BE. So we have AB is 9, BE is X. So we have 9 plus X. Then we have times BE, that is X, is equal to CE, that is 20. And we square that. So we now have X squared plus 9X is equal to 400. X squared plus 9X minus 400 is equal to 0 by addition property of equality. Now this is a quadratic equation. You can use your factoring techniques to get the value of X. So we have X plus 25 times X minus 16 is equal to 0. Then we have two values for X here. We have X is equal to negative 25 and X is equal to 16. But we only accept 16, the positive, because we don't have any negative measurements. So therefore, the length of BE here is 16 centimeters. Right? So it's reflection time, my dear students. Angles are formed by the intersection of chords tangents, and secants. Their measures can be obtained by their intercepted arcs. Likewise, each individual's character is formed by the people surrounding him, his family, close relatives, friends, teachers, and classmates. What character is added or subtracted from you? And whose influence does this character come from? So try to reflect on those questions. For the things to remember in this lesson, we have the first two theorems over here. This is for the angles. Theorem number 1 states that the measure of an angle formed by two secants of a circle intersecting at a point in the interior of the circle is 1/2 the sum of the measures of its intercepted arcs. Theorem number 2 states that the measure of an angle formed by two secants, two tangents, or a secant and a tangent intersecting in the exterior of a circle is 1/2 the difference of the measures of the intercepted arcs. For the last two theorems, this is for segments. Theorem number 3 states that if two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. And lastly, for theorem number 4, if a secant and a tangent intersect in the exterior of a circle, the product of the lengths of the secant segment and its external secant segment is equal to the square of the lengths of the tangent segment. So here may be some frequently asked questions about the topic. Question number 1, what if we have a secant and a tangent intersecting on the circle? Again, what if we have a secant and a tangent intersecting on the circle? Well, it works like an inscribed angle. The measure of the angle formed by the tangent and the secant intersecting on the circle is 1/2 the measure of its intercepted arc. Again, it's 1/2 the measure of its intercepted arc. Let's go to question number 2. Is theorem number 1 also applicable for chords? Again, is theorem number 1 also applicable for chords? Now, since chord is contained in a secant, the answer is yes. Theorem number 1 is applicable for chords, but only theorem number 1, not theorem number 2 to 4. Question number 3. How do we get the measure of angles formed by two secants? Again, how do we get the measure of angles formed by two secants? Well, anak, it depends on the case, no? Whether the point of intersection is inside or outside the circle. Okay? If it is inside, you use theorem number 1, the addition part. If it is outside, use theorem number 2, the subtraction part. Alright, so for your home learning task, you answer this activity, the what's more part, on your module number 6. This has been another Valenzuela live session on Mathematics 10. Once again, I am Sir Neil Raymond K. Factor from Mapulang Lupa National High School. Have a nice day.